All right, folks. So today I'm going to talk a little bit about data. I think I understand some of you are students, some of you are working professionals. So how many of you have worked with AI before? Or is it? Yes, no, I don't see too many hands up. Okay. And by AI, I don't just mean, language models, right? Like even machine learning models, regression, all those comes under AI. Right? So how many people have worked with it? I still see some pockets not raising. Maybe they are shy today, but okay. All right. So today, now I think all of us have used, life and everything, right? Now, what is one of the, like how do we get here, right? How do we get to the GPT? What happens behind the scenes, right? Anyone? Transformer architecture, good. And then what do you show the transformer architecture for it to learn a lot of these things? What you show the architecture is data, right? The tons and tons of training data, which goes and the transformer architecture sees all the data, learn from the data, understand patterns, and then when you ask it something, it mimics those patterns which is already seen. So I think a lot of us, I think we start from opening ChatGPT and start interacting with the model, and we believe that's the AI. I think there's a huge thing which supports it, which builds it, which enables it. And that's what today I'm going to talk about some of those areas, those issues, how we solve it, and things like that. So that's what the title of the talk is around data. So we're just going to talk about data. What is data? Why is it important for AI? Right now, just to kind of set the stage of why we are even interested in data, why we are interested in AI. So if you look at some of the numbers, right, I think just by 2030, right, not even like, 2050 or 2100, like it's just that 4 years, right, 4 years away. Right, all the studies, right, from PwC and other institutes, they are predicting a $16 trillion impact which AI would have on a day-to-day life, right? And that's going to be broken into kind of two parts, right? One is 6.6 trillion comes from, how our work will get faster, right? We will be able to do more things, in less time. And many of you have seen that, right? How many of you have used, right, Copilot or, Codex or, right, to write the code, right? All right. So now more hands are up there. So you know how fast it is, right? Like what used to take us weeks to design, write, debug, you could almost write a prompt, go for coffee. By the time you come back, the code is ready, the UI is ready, everything is ready, right? So that's the increased productivity part. But then I think we are also hoping and not just hoping, right? We know that there are going to be a lot of new consumption patterns are going to open up because of AI, right? New kind of ways people will use AI. And that's going to be even bigger, right? Like $9 to $10 trillion from the consumption effects. So net, I think huge potential. And that's why, all of us are talking about AI. Now, that's good, right? Okay. Now, if you just look at AI, right, what are we doing, right? We are going through this shift. And I think, we are calling it fundamental shift, but I think the definition of fundamental is very different, right? Earlier, when someone used to say fundamental breakthrough, it used to be like 5 years, 10 years, 5 years in laboratory, then I think small scale deployments. In 10 years, right, each one of us will actually get hands on that technology. Right now, I think, fundamental is almost like, 3 months. Someone releases it, puts in open source, and boom, we all have it, we are all playing with it. Right? So what we started, right? We started with AI that could generate for you. Right? You could ask AI to, okay, that here is my half of my sentence, you fill the next half. It used to do next token prediction, text generation, pattern matching. That's the AI, that's what we are calling it generative AI. It could generate for us. Then the next phase of generative AI came when it could actually, right? You could have a chatbot and you can go back and forth and it will remember all the context. It will remember all the information you asked. If you said something that I don't like it, it will remember that you don't like it. So next time those kind of text is not generated. Right. So we are getting into assistant mode. And then I think, with whole of this agentic AI, we are actually getting into what AI could do for you. Now, I think if you look at, a lot of the open clouds and other things, you can just tell that, go and clean up my inbox. And if you look at your inbox, it will apply some rules, keep you in the loop, but it will just do it for you, right? You ask AI that, okay, I want to go to trip somewhere, suggest me everything from from my home, I get to airport, from airport to hotel, what should I visit, what should I buy, eat, come back. And that's it, right? It will just do it for you, right? If you provide enough tools and everything, it could even do bookings and everything for you, right? So that's where I think, we have gone, right? From AI, which could generate the next token from you, to AI, which will chat with you, to AI now, which can do for you. And this fundamental shift has just happened, I think, maybe 2 years, 3 years. That's what it is, right? In 2-3 years, we have gone from simple token prediction to AI, which is just autonomous and doing everything for us. So that's good, right? So which is it? And then I think I don't even know what could be next, right? We're talking about AGI and other things. Who knows, right? What will be next? Now, I think one thing which people would always think, right, that okay, right, we already have ChatGPT and Claude and other models. They have almost seen every data that exists out there. So all the data which is on public internet, books, newspapers, they have seen all. So you ask it anything, they can answer you based on the public knowledge. And what's left, right? Why are people still interested in building new models and everything? So one of the things which we have realized as as a company is that there is a lot of knowledge which is behind the firewalls, right? Which is within the company. So I would have, let's say, for example, right, I would have a lot of my, not just me, right? Let's say, like, if you look at example of Flipkart or Facebook or Flipkart, Amazon, they would have a lot of data about like customer tickets, right? Customers' complaints. That data is not publicly available. So how do you make use of those things to improve the models, right? Because if you are building something which is very, very, right, kind of specialized to handle, let's say, tickets data, then I need all that data, which is not available outside. So that's where I think, we did some study, right? We did some study that, how do things line up? And I think our hypothesis is that small models, if you show small models correct data, they could actually do better than larger models which have not seen that data, right? And that's why I think, this is just being toward the data, why I think data is the most crucial thing. And if you look at some of these numbers here, right, I think for some of the tasks, right, like if you look at the first one, right, first one is question answer over standard operating procedures for, financial company. So these SOPs are internal to the company. And if I take a small model, right, which is 7 billion parameter model, and train it, it's 95% cheaper, and I think at least 3 to 4% higher accuracy, right? So, and again, right, you can look at the trend everywhere, and this is not just our trend. This people will tell you everyone is observing the same trend. I think that's why there's a new phrase for that, right? SLM, small language models, right? Where you're saying that, okay, I'm going to take a small model, and I don't care if my model can write poems. I don't care if my model can help you get from hotel to sightseeing, right? I don't care. What I care is that my model should be able to answer customer queries on my products. So for that, I will be okay to let go of some of these other functionalities, but really focus on one particular task. And that's where you get it. You get small models, which could even sometimes run on laptops, which could do few jobs very well, and they don't care about other jobs, which is fine, which is okay, right? Not everyone. So the key thing here, data. You show the right data, you get much better performance from even simple analytics. All right. Now, anyone can, it's there, but still, right? Anyone has seen this picture before? Anyone? No? Right. So this is a picture by Aisha, which is a hand drawing hand. You don't know which hand is drawing which hand. And that's what I think the data lifecycle for AI is, right? That you take some data, which is used to train the AI. And then once you have the AI model, that AI model is used for a lot of other data tasks, right? So it's circle. So data for AI, and then AI for data. Okay? And that's what we're going to cover today, right? But I thought that this picture kind of really mentally captures that whole thing, right? Pictorially, that hand drawing hand. Okay. All right. So we've only seen this, that, there is data, and this data everywhere is also, right, from a poem, right? You would have, that poem everyone would have read at least, right, in your high school. Water, water everywhere, not a drop to drink, right? So this is what it is, right? That we have data everywhere. But then how do we make use of the data is going to define which LLMs actually work in which tools. So, why is it such a hard task? Right? Why is it such a hard task to prepare the data for LLM applications? So one is, the first problem is really, right, deduplication of documents, right? I think, even on your laptops, you will have file version 1, version 2, version 3. Sometimes, you put a dot September, dot October. It's the same file with like small changes, but it's all over the place, right? Now think about it, right? If you don't do deduplication, what's going to happen is the model, which is in the learning phase, is going to see same document again and again. And it does not know it's looking at the same document, but it will actually assume that I'm seeing a very, very important fact because I'm seeing it so many times. And it's just going to overlearn that thing. So extremely important to do the deduplication, right? Then I think we have data in PDFs, right? We have data in, Excel sheets where you have column text and there is a lot of text there. We have Word, we have all kinds of formats, right? How do you extract the text out of it? It's not easy job. I think especially PDFs, because sometimes you'll have PDF where the table is like, the last table is going to be like 90-degree rotated, which is difficult to parse, understand, maintain the semantics and all those things, right? So extremely important task. Remove excess markups. You will have, right, in there a lot of font information, a lot of paragraph information, all those things. And then document quality is very important, right? Like just because you can do deduplication and remove text, if the document is bad, it's just going to provide bad information to the model. And then the last thing, right, is very important, which the industry participants will kind of appreciate more, which is sensitive information detection, right? You don't want your models to start learning phone numbers, addresses of people, and start emitting them in some other chat. So I think it's very critical before we provide these documents or these chunks for training. A lot of the PIIs, SPI are removed. And again, right, it's also not just a sensitive information, right? Sometimes when you go on the web, I think the document could contain, right, bad words, and poor thoughts, not so good representation. And you learn all those things, your model is going to mimic, start saying bad words, bad thoughts, all those things. So you definitely want to handle that. Similarly, I think, if you look at code world, language detection is very critical, right? You definitely want to, if you are trying to train a model which is going to emit Python code, ideally you would like it to supply Python language. Malware detection, right? You just can't go on, public GitHubs and say, I'm going to scrape all the code and start training my model based on public code. So the public code could have the malwares, which could, what it means is at some point of time, your model is going to generate code, which could have a malware inside. And the code quality, right? Like how many times have we written code where variable goes from I1 to I4, I5, and when you run out, sometimes it becomes II. How many times? Come on. All of us have done it, right? All of us have written that code, right? Which is variables are ABC. Only we can read it, we can understand it. So the code quality is very good, right? Otherwise, that's how the model is going to produce code, right? No better than what we write. So critical things to do, and you can see, right? Like we'll go over some of these problems in a few slides, but you can see each one of this could be solved by AI, right? So all this require AI to actually look at it, right? Okay. So what have we done? So what we have done is we have created this toolkit, which is called Data Prep Toolkit, and it's a public toolkit. It's an open source toolkit, and what it does is it has a lot of the things we talked about, right? It has deduplication, it has programming language selection, filtering, chunking, document quality identification, PII detection, and you can. It's highly scalable. You can run it on laptop, and you can run it on large clusters, and it will do it. So I think on the input to the data prep toolkit is going to be your PDF documents, your HTML documents, your Word documents, GitHub links, code, and then it will do all the things which you want to do. It's all kind of configurable, and what it will provide you is the data, which then you can use for fine tuning, RAG, instruct tuning, whatever you want. Right. So I'm going to stop here for a minute and see if there are questions, and then. And no questions, then we will move. But I think, any one of you who would like to learn a little bit more about data preparation, I think you should definitely go and look at this toolkit. It has a lot of tutorials, a lot of examples, a lot of data set which comes back with. So you don't have to do everything from scratch. You can just use it. All right. Now, ETL. How many of you know ETL? What ETL is? Extract, transform, load. Good, right? So that's a good kind of definition. What I think ETL does is very simple. I think what ETL does is you have some data in, let's say, data source A. Let's say you have data in Microsoft Excel, and you want to say, I want to provide this data so that everyone can use that data for SQL query. So what I'm going to do is I'm going to take the data out of Microsoft Excel, which is extract. I'm going to do some transformations so that my date format matches date format of the Postgres or DB2, and then I'm going to load this data onto DB2. So extract, transform, load. Right. So that's what ETL does. Now, this is a very simple example where you have one source and data just goes into from one source to one target. But in real life, you would have complex flows, right? Where you will say, okay, pick my data from these 5 sources, then merge them. While merging, look at some of the data as master data, bring it in, and do all kind of transformations before the data gets ready for consumption, right? And we have been writing these ETL job flows with hand a lot, and it gets into a lot of issues because they're fairly complex. It requires lots and lots of skill to write a very efficient and correct ETL, right? But now I think what we could do is we could actually do it through natural language, right? Using a kind of generative model behind it. I could actually provide a natural language utterance, and I can carry it. Right? So let me show you this small demo video. Okay, it's too small. Anyway, I think I can share it with you guys later, or the links I could share. They are on public as well. But what it does is you can ask that I to connect my Excel data, merge it with a CSV data which I have, and the merged data I want to put it on DB2, and just enable this thing. And in between, make sure that you don't introduce any duplicate data, or remove all the duplicate data and all those things. Right? And I can give this complex natural language utterance, and the system will be able to create my ETL flow with what we. Now the difference I think is that if you do it through code, you will get a bunch of code where you have to manage. But now I think there are tools like data stage and other things which already has built up these capabilities, right? Like they have a connector to CSV, they have a connector to DB2. So our ETL generator, tool will use those connectors to almost like I'm just going to build this pipeline for us. I think. Stop it. I can't stop it. Okay. So it's going to build this kind of pipeline for us. Each of the pipeline has a lot of parameters it can ask. Right? For example, if you want to put something into database, it will ask your credentials of the database, port number, all those things. And it can ask all those things either through user interface, or it could ask you through natural language chatbot, right? It could ask, okay, I have configured database. What's the username? What's the password? What's the port number? You provide all this information, and while you are like having a cup of coffee, you can just provide all this information. By the time you finish your coffee, the ETL is going to be ready and done for you to be used. Right? So that's a great example of how we are moving towards higher productivity and removing the barrier, right? Because a lot of these things, like I said, right, require specialized programming language, right? Knowledge requires specialized knowledge about how the databases work, how the ETL works, how to make it optimized. But now a lot of those things are done like this. And the way I think we are able to do this is actually take a small LLM and show it a lot of historical data flows, ETL flows, along with the handwritten natural language, right? So we have the flow, but you recall, right? I think earlier when people used to do, they used to come to some platform and either write code or drag and drop these kind of transformers to build the flow, but we don't know what the flow is about, right? So we had to actually take these flows, convert these flows into natural language by hand, and then we have the training data, right? I have the natural language, I have the flow, and now I can train. So just one more example of how things work. Go ahead.
So one thing, since you speak about the fine tuning and everything, right? So let's say we take a small model, and we wanted to fine tune it on a big functionality, right? So approximately, what would be the effort that would be involved in fine tuning that particular model, or the number of datasets that we might need to provide? Let's take a simple example, right? Let's say we wanted the model to be trained to pick up the political news from the daily news article that has been published from the internet, right? So we can get n number of data from history, and we can feed this to the model and get it trained. But approximately, like, what would be the number of data sets that we would need to tell you? And what would be the cost that would be involved
from our own experience, right? So there is a, not from political, but from some of the other. There's a language known as GraphQL. Have you heard about it? So GraphQL is a language which is used, it is like SQL, but it could query multiple data sets at the same time and get you the answer. It doesn't go into detail. But I think GraphQL was is a niche language. There is not too much publicly available data sets for GraphQL. So that's why I think a lot of the out-of-the-box models were not doing very well on GraphQL generally. So which is the same thing, right? We provided it natural language, query, and I think with like some, I would say 3,000-4,000 samples like this, we were able to get it very nicely. And so I don't think it requires that much data, but and I think it's getting better and better, right? We believe that soon I think we'll be at a stage where I think it's going to be almost like model first. So a lot of these things which GraphQL, SQL, it's just going to be come out. Like models just know these things. You only have to supply very small specialized knowledge, which is very, very kind of customized for you and provide. That's going to be very small. So I think it's just we are getting to a place where I think it's, plus I think there are a lot of other libraries which will help you do RAG, fine tuning, tuning. So you don't have to spend time. The only time you have to spend is to curate this data set. So yeah. Depends on task to task, but I think for language tasks, for GraphQL, now we have seen small data sets.
So here as well, you have used a small local model Spring.
Yes. All right. So we'll move to one more application, which is both, right? I think which needs AI to solve, and then it's very critical for it to be used by anyone, right? So semantic mapping and transformation, right? I think maybe it's here, but can anyone guess what it means, what it will mean, why is it important for anything? It should be there. Okay. So relationships, I think someone said, I think that's correct, right? I think, but that's like even more advanced, right? I will give you a simple example, right? you have two data sets. And you want to say, okay, I'm going to move my, right, I'm going to merge both the data sets. Very, very simple task. No complexity, simple. But now I think what happens is that in one of the data sets, you have a column first name, you have second column last name. In the other data set, you have a column which is saying name. That's it. Now, as humans, we understand, right? First name plus last name equal to name, right? But how do we kind of do it at a scale, right? Where you are saying that, okay, on my left-hand side, I have data sets which has like, few thousand such columns. On this side also, I have few thousand such columns. How do I automatically come up with this thing that, how my column, how each of my column from my left-hand side will move to right-hand side, right? So that's your one definition of mapping, where you are saying that, okay, I'm going to create a map between source and target, column by column, right? It could, and it could get more complex, right? So for example, on this side, you could have something like date of birth. And so, for example, right, even for our, Aadhars and all, Aadhaar card, when it was first made, I think it only had date of birth, right? Not date, right? Year of birth. It didn't have the full date. Now it has full. But I think I'm sure, right? If you are building a system, you need to be compatible with both kind of, systems. So how do I say that, okay, date of birth, year of birth, I can extract out, right? I can extract the year and fill it in. Sometimes it's date of birth, and in this one you have age, right? Which requires a little bit more, right, skills to do, right? So that's what semantic mapping means. I think you want to map which column goes to which column, right? So that's simple. That's the first aspect of semantic mapping. Now, what we have seen is that many times you can do this mapping, but then the actual data also needs to go through transformation. So I have figured out that first name plus last name is equal to name. But now when I start to look at the data, it says that, okay, on this side you have Sameep Mehta, but on here you only have like S dot, which means even though I map the right columns, I can't just move the data as it is. I need to apply some transformation on the data to move it, right? So with these two things, I think we could get a pretty good handle on how the data get moved, get integrated, get combined, right? So you first figure out which column goes to which column, and then you figure out how the data from this column will go to this column. It's just going to be direct copy, it's going to be transformation, and we have seen it, right? Like if you have ever used Excel to merge multiple files, we all know how the date format confuses all of us, right? Sometimes it's right year first, sometimes month first, sometimes day first, then sometimes someone will use date time format, where it's like date followed by the HHMM SS format. So all those things we have to handle, right? So that's what I think the semantic mapping and transformation does, right? And again, right, to go back to my previous argument, it requires like deep AI algorithms to do this mapping, because that's why we are calling it semantic, right? It's not about date maps to date. Sometimes you could have zip code on one side, and you could have actual physical location name on the other side, right? You could have 560077 on this side. You have Thanisendra on this side. Someone needs to say that, okay, they are the same. They're talking about the same concept. They map. So I'm not, even though I think if you look from a pure, if you remove the semantic part of it, if you look at pure technical point of view, there is one column which could be integer, or right, other column which is string. You do string match, there is no match. 560077 does not match with Thanisendra with any string, any distance, anything you do. And that's why I think those semantics are very important. That's how you match things, right? And then you transform the data. And again, right, you could kind of just imagine if you have 100 to 200 fields this side, 100 fields this side, how much effort it will take to map each one of them, especially if you assume that the mappings are going to be, one to many, many to one. Sometimes, right, null mapping, some columns will not map anyway. It's just going to be very, very error prone, and more than error prone, I think, after a while you will just give up, right? Like, you do this mapping few times and then you say, it's not worth it. So that's what. But then I think also see, right, let's take a step back and see why this is important. So this is important because, unless I do this, I don't get a uniform view of my data, right? I think I don't create a clean data set which I could use for training, right? Because my two data set, one has zip code, other has location, talk about the same thing, but I can't use it unless they map to each other. I can know the transformation. Then I can use this single uniform data to teach some model about the zip code, location, and other things. So there's a demo here, which I think again, right, I don't think going to be useful to play on the screen. I think it's small screen here, small here. I'm going to share the links with you guys. Okay. So that's good, right? So we talked about few applications. Let's look at one of the, right, I would say, if not the most, then I think, at least right, top three, which is metadata enrichment. Anyone can tell me a little bit about metadata? What do you mean by it? Sorry? Very good. Yeah. So that's a small piece of information which you attach to your data so that the data becomes more meaningful, more useful for everyone. Right? So for example, I think if you are running a, let's say, marketplace, when you have a lot of customers, a small piece of information to say which of my customers are high value customers versus low value customers. That's a metadata for it. That's very important. Right? Sometimes this metadata could be very, very technical metadata, like saying that I have a column. This column is of type integer, and it can take these values. Right? That's my technical metadata. Why is it useful? If I have that information, then as soon as I need to add more data to that column, I could just check whether the new data is integer and has these values. If not, I know adding that data into my column is going to result in a poor quality data. I could add, but it's not going to be useful. Right? So that's our technical metadata, right? And the list is long, right? Technical metadata, you could have, profiling, you could have quality, you could have whether the column has sensitive information. If the column is social security number, you can add that thing and all those things. So that's our technical metadata, which basically means I can learn everything from the data which is in front of me. Right? Then I think what happens is you could have, in many cases, right? I think, have you anyone worked with the databases here? Postgres, SQL, anything? You have, right? You worked with Postgres, right? So, and how many times have you created a table where the primary column is named ID or serial number? Multiple times, right? But each time your application is different, right? Sometimes someone is making a library system. When they say ID, they actually meant book ID. Sometimes people are making attendance system. When they say ID, they mean student ID. People have used products, but everyone is thinking, it's ID, right? For me, it's ID. But then I think about it, right? Like, I think, 10 years down the line, 20 years down the line, when all of you would have moved, some new guy will come and say, oh, I have like few applications, few database systems. Let me try to clean it up. He will try to do semantic mapping and say, oh, ID matches with ID. Wow, hey, I'm done. And then suddenly, book ID is matching with customer IDs and other things. So that's where I think comes the business glossaries and business metadata, where you say for each column, I'm going to assign what does it mean for my business. So you all could have IDs, but then there will be another piece of information which says this ID means student ID. And some other application ID means book ID, right? So between technical data and technical metadata and business metadata, we have the full knowledge. I know exactly what this column means for my business. I know exactly what is the profile of this column. I know what kind of data is contained here and what is the quality, all those things, right? It's a large area. You can keep adding metadata, right, forever. But I think this, is really, really, really critical to do any AI on top of the data. You have to have semantic understanding. You need to have metadata which explains the data, right? I'll give you a simple example. If I ask something like, give me top students, Right? What does top means? Right. That is going to come from business. So it's like it's not just maths, right? Everyone could have a different definition of top, right? Sometimes some organization might say my top means 95% and above. For some other organizations, top could mean 90% plus active in sports and something else, right? So all those things actually go here. So that when someone asks a natural language question, I could actually convert that natural language question using the business metadata to what it means for this particular application. And that's something, right? This is very important. This is almost like saying that I have some raw data, which is like, tables and columns, and I put a lot of meaning around it through this metadata. And without this meaning, you could have lots and lots of data, but you will not be able to use it. So very important to think about metadata. Okay. I think we talked about some of these examples, but you can look at it again, right? A column which is of type date. So your data class is date, technical metadata. The column name, which was, okay, sorry, I'm sorry for the font, but it says PLN/END .dt. So plan and date, but not written in the way which is understandable. Understandable on slides as well, right? Oh, sorry about that. But then I think what we do is we expand it to say, okay, plan date, right? And then I provide the description of the call, that this is the date the communication needs to be completed. And more, right, information around that. Now, I need to find all the rows where the communication had to be completed yesterday. I exactly know I need to go to plan date and do a filter by it. Right? Otherwise, without all this information, I don't know what plan end date means, right? Not even just plan end date, right? I don't even know what PLN/end .det even means. So this is really critical. And like I said, right, we use a lot of AI to understand the columns, to understand the profiling, to understand what it means. And then we use it for all our tasks which need to use this data for right, information gathering. All right. Okay. I think I'm going to skip this, son. This GraphQL is what I was just telling. I think, this was what we did. And there are some papers around it if you are interested, just to see the data set size. I think you could look at it. Okay. The other thing I think, which is where I think a lot of the power for LLMs could be extracted is what we are calling is story generation, right? So what it means is that I think, if you could understand the intent behind the question, what the user really wants to know and ask, then can you provide all the answers to the user in one go, as opposed to just providing what it's asking and then going back and forth, right? So for example, right, if you have something like this, right, what trends can be observed in sales of different product categories? Then, instead of just saying that, okay, here is a trend, can I actually, of course, I provide the trends and then provides a little bit more information around the trends so that, the consumption part is much more clearer. We provide charts, we provide bar charts, numbers, everything. Can we do that? Right. So that's what we are calling data story. It's almost like, creating a story around the data based on the intent of the user, right? So what you see here and a little bit blurry font is just from this simple question. This whole thing was created, and this is not even the full one, right? So from sales, I think we are also, so for example, right, if someone is interested in sales, and our friends in business will agree with us that I think when someone says sales, I think, and when sales go down, the first thing people say is, okay, how many people were employed there, right? So we provide that information, right? That here is the employee count versus annual sales. How much were spent in IT for those things and all those things, right? Because that's how people want to know, right? No one wants to just know the sales number. Everyone wants to go deeper, say, okay, if my sales were good, what exactly happened? Why did they went up? If they're low, why did they be low? Where I could optimize and all those things. And think about it, right? Just to answer that question, what trends can be observed in sales of different product categories? you need to understand a lot of things, right? You need to understand what trend even means, right? Because in your database, there is no column known as trend, right? All you have is, your columns, descriptions, metadata, and all those things. So you read, understand all those things, and then you try to generate this kind of story, right? So that's good, right? So I think we have seen a bunch of things happening here. Right? We have seen metadata, we have seen text to questions, we have seen that's fine, right? So many things happening. Right? How does all these things come together, right? So the way I think these things come together is this new upcoming area which is called data ops, where what we are saying is these are the three core principles of data ops. Right? Your data you have to have end-to-end efficiency, which means that your data need to be high quality to start with. It needs to be stored in an optimized fashion. And anyone who wants to access the data should be able to do it very, very effectively and efficiently, right? And you see, right, from these three things, right? Like if you remove any of those things, it just becomes very suboptimal system, right? You could have great quality data. You would have stored it in a perfect fashion. But if people can't access it, people can't use it, then it doesn't matter, right? We have done all that work for nothing, right? Similarly, I think if a lot of people want to use some data and we have not, right, we are not managing it properly, then it's going to be high cost. People will still use it, but it's going to be high cost, right? Secure and compliant, we touched about it. Data quality, higher data quality data. And then, of course, right, governed. Only people who should be able to access the data, who are allowed to be access the data should be, provide the authorization and all those things. Right? And this is a big problem, by the way. Right? I think once we move to agentic systems, I think this is coming up even more because it's very difficult to tell the agentic systems on what they should be telling and what they should not be telling. So very, very important. And then, of course, right, the data cost has to be lower, right? Which means it has to be optimized and we can do it. Okay, let's see one example, right? What are we seeing, right? So what we are saying is the following, right? This is our problem statement. So we are saying that, okay, we have seen, how I could get the data using AI, how I can clean it, how I can store it, how I can add metadata to it, how people can ask questions to it. All those things can be done in a kind of through agentic AI system. We can do it. We know how to do it. But then I think, is there an opportunity to almost say that, okay, can I create an autonomous system where, all these different agents talk to each other, work with each other to solve the problem and to keep my data optimized. Right. So that's the goal, right? That, how do we create this? Right? So I'll show you an example. It will become clear what we mean, right? All right. So this is it's a three-part example. The first part really is a user comes and the user wants to access some data. So what the user is saying that, okay, I want to create financial data product for the funds which invest in technology and blah, blah, blah. Right? Basically, that's the only data which I am interested in. And I come to a system and I say, I want this. Right? Now, what happens is the following, right? Let's say it. So someone is giving the business justification on GitHub. Someone created an issue on GitHub that, a new data request has come. Here is my agentic system, which are monitoring it and saying that, okay, let me try to do something about it, right? If someone is asking new data, I will do it. Right? What it does, it goes to the data lakehouse, which has hundreds of data, right, schemas and everything, and it will try to extract the column which help in answering this particular question, which is mutual funds for IT industry, right? And don't worry about all these things was happening, but I think eventually, fast forward anyways. So what is happening is that you are creating that very, very specialized data product, which I think, if you've used Postgres, you know that there is something known as view in the databases, where you create you pick the columns which you are interested in and you create a virtual table around it. So that's what is going to happen here, but just more, in a business setting where you're saying, okay, I'm just going to tell my natural language and let it do the job. Right. So see, here I think it has created my data product, right? If you look at this, I'm going to stop here. Here, right? Finance data product. And it has created my data product. It has created mutual fund, information, investment strategy, and all those things. Whatever I asked in my natural language, it has created my data product with multiple schemas. All right. So that's good, right? So I say, okay, we are good. Now let's move forward. Now let's move forward, right? So now what has happened is that someone asked a question, I created a data product. But just like anything else, this data product needs to be evaluated. Someone needs to go and check whether what I have created versus what I wanted, they are actually in sync or not, right? And that's where some of the concept of data story comes into picture. So what we do is we say, okay, I know what the user wanted. And what I'm going to do is I'm trying to capture its intent and create lot of other questions. So here, right? So these are the system generated questions. So system has generated questions. Assuming that if the user is asking for mutual funds, then someone is definitely going to be interested in which investment style has the highest average fund returns for last 10 years. That's how usually we also do, right? When you try to invest something, you see what was last year return, 3-year return, 5-year return, inception, and all those things. So we create all these questions. And if you see, some of the questions have failed, right? Which means that this data product is not complete. It needs to, like, there has to be something has to be done to it so that all the questions succeed, right? So there are some questions which are failing, right? And right, I think all this is happening autonomously, right? There is no human intervention apart from the first one where the human said, I want this data product. Everything is just happening, right? So now I think, if we just go back for a minute, okay. It's actually saying, okay, I'm going to look at one of the error class. So here, so it took one of the failed cases, analyzed it, and created this GitHub issue. The issue is that particular question took a lot of time. It took 5.57 seconds. And we wanted all the answers to be in 4 seconds. It took more than 4 seconds, and that's why it failed. And a GitHub issue is created. So someone can look at it. Who is that someone? That someone is another agent. It's not a human. It's another agent which is monitoring the GitHub to say, okay, are there any issues coming up? Are there any issues coming up? As soon as the issue comes, it takes it, right? And, now I think, okay, it does some diagnosis to say, okay, why the issue is coming. And I think, if you move to next one, okay, this is it. So now I think it took that issue again and said that I'm going to clear. It's asking that, can you diagnose the issues? Right? And some agent will go and say, okay, let's see what's happening. Why is it slow? And it comes back with some recommendation, right? It said that, okay, there were not enough indexes built on the database. And that's why I think it's kind of slow. Okay, I'm also going to generate code for you, which can generate the index for you if you're okay. And as soon as the human says, yeah, go ahead, execute it. It will go create the index in the backend kind of table. All this information is available for us. And then it says that, can you test or not, right? Whatever you have done, has it actually changed anything for you? And then it will say, okay, the new SQL query ran in 3.82 seconds, which is less than 4 seconds, which is what we wanted. And hence I have solved the issue, right? Now, all these things are happening kind of autonomously, right? I think even though I'm showing you a step by step, it's, multiple agents, right? There is an agent which is which is listening to what people are saying and creating these data products, passing it on to another agent, which is saying, okay, I'm going to independently validate whether the data agent is created, whether the data product is created properly or not. If there are issues, it will raise GitHub issues. And another agent, which is the diagnosis agent, keep looking at GitHub issues and say, okay, a new issue has come, let me try to solve it. And then pass it on to the agent, which is actually going to apply these patches. Finally, test it and then commit the changes. And all this is happening through GitHub so that, next day someone could come back and look at it and say, okay, I want to see what happened last night. I want to review everything, and everything is there. So this, I think, if you think about each of the step itself is composed of multiple steps in there. It's not easy to go from a natural language to data product. You require high quality data. You require technical metadata. You require business metadata. You require all those things, right? Understanding what the issue is very complex, right? Especially in the large systems. You really figure out what's the root cause of the issue, right? And then correcting it, right? It's you need to know what's the best way to correct it, right? There could be 5 different ways to correct it, but you have to figure out which one is the most optimal way of correcting it, which will cost you the less, and then not disturb something else, right? Because the systems are very well connected, right? It's not just one user, one system, right? Multiple people are using the system, so all those things. Okay, so I'm going to kind of over the time here, but if I think data research, I think a lot of us, I think, when we think about AI, we directly jump to models. And at least, right, we believe that data research needs very, very special and dedicated focus. That how do you make the data available to everyone? How do you make sure your data is useful, which means it can talk to other data sets, it could link, integrate, it's governed so that, we don't leak data. And then it's self-correcting. I think that's very critical, right? That's how I think that's what differentiates AI systems from non-AI systems. That the AI systems could, right, kind of learn from feedback and correct themselves so that they are better next day and next day and next day. I think a self-correcting is something which happens on the model side, but I think we start to think about, right, what does self-correcting mean for data as well? Right, like I said, right, I think there are lots and lots of opportunities to do fundamental work here. Because right now all the examples we talked about just the table, right? Tables, right? But then the world would have tables, world would have images, it will have like text. How do all these things work seamlessly? Like, how do we shift between different programming languages? It may happen that you need to use a combination of, let's say, Python with SQL to do some task. How do you do that? Right, I think infusion of domain knowledge to make sure that the LLMs are working fine, and then extending it to non-text domain, images, videos, everything. It's upcoming, but I think these are still a lot of open questions where each of these bullets could take like lots of people with lots of months to do, but at high level, that's what I think. Okay, I'm going to stop here. See if there are questions, comments. Anyone has anything?
We have to choose between training a model and building RAG out of it, which is more sensible and cost effective.
Of course, right. I think training from scratch is always going to be very, very expensive.
Okay, so for instance, let's say if I train a model, is there a way to untrain it again?
But that's a huge research area right now. That how do you tell the model that can you unlearn some things? Or I think especially with all this consumer protection thing that people could say that forget my data. Right. So I think if GDPR, the global data protection. So they have a thing that the consumer could come to the company and say forget about me. You can delete the data from tables. That's still a hard task, but it's still easy. But then I think those tables have already been used by a model to do something. How do you unlearn this? I think it's a huge research, open research areas.
Okay. Thank you.